Hi everyone. This is Anurag, again co-founder at TrueFoundry, where we are building ML platform for companies to get started with ML and scale quickly. And today we have Arpeet with us. Arpit is one of the founders at Builders Fund, where he and his colleagues invest into ML AI companies across the world. And at the same time, he is the head of infrastructure at Skiff. Prior to this, he was the engineer. He was one of the part of the engineering team at Salesforce that built the entire ML platform, and currently he also advises a number of companies in their ML AI journey. So, Arpit, it's a pleasure to have you. Thanks a lot for taking time. It will be great if you can maybe introduce about your journey with ML and what you have been up to.
Yeah, yeah. Thanks, Anurag. Thanks for having me. Yeah, my journey with yeah. So I came to these states to do my master's in information science, specializing in data science, and so that's really how it began. During my master's, I did an internship at MetaMind, which was a really tiny startup back in 2014, and I joined as full time later, and then we were acquired by Salesforce, and that's how I ended up at Salesforce. So yeah, that was basically the journey. But yeah, MetaMind at the time did build a deep learning based ML platform where we were focusing on mainly two use cases: NLP and image classification. Once we ended up at Salesforce, we obviously started focusing on enterprise AI use cases, and so we ended up building a pretty large machine learning platform with support for products like chatbots in Marketing Cloud and Service Cloud, which are one of the two products at Salesforce, one of the many products actually. So yeah, there's Marketing Cloud, Sales Cloud, Service Cloud, Analytics Cloud, and so on and so forth. So yeah, basically we built a platform where you could, as a Salesforce customer, come in and train either an NLP model or a vision model, and then plug it into your CRM workflows, um, and get real-time insights, as part of those workflows. Yeah, that's the AI journey. Yeah,
Awesome. And Arpit, how do you kind of currently you advise a number of companies on MLI? Like maybe if you can just tell which companies and what do you help them with, that will be great for the audience to set context.
yeah, it's pretty interesting. I typically advise anywhere from buy versus build decisions to hiring to technical roadmap and even tactical decision making around how to go about building an ML stack, what type of tools they can use or leverage or build even in house. Um, Infrastructure is obviously a big part of that. Cloud cost optimization, um, positioning, GPU resources, for training and prediction. So yeah, a lot of variety of things under that umbrella. Yeah.
Interesting. So Arpit, we will take this call to dive more into the ML platform at Salesforce that you all built, and where you kind of almost build, as you said, the world's number one enterprise AI platform. So let's dive into that a little bit and talk a
Sure.
little bit about the use cases
Yeah.
that the AI platform at Salesforce served for its customers. Maybe we'll start there.
Yeah. It was pretty exciting. This was from 2016 all the way to 2022 while I was there, and at the time, although there was data, there was a lot of gap, taking like making use of the data and generating a model and putting it into production, right? That was still a very core set of problems that we were trying to solve. So yeah, the use cases were chatbot for Salesforce Service Cloud. There were object detection, image classification use cases for marketing cloud. and then just general NLP use cases around like intent classification, sentiment classification, NER, which is named entity recognition. So a lot of these use cases, and the challenge was, how could we take Salesforce data, especially Salesforce being a multi-tenant system, right? So there's like multiple thousands of customers, and each of them have their own data, and each of them operate in a different domain, right? So there's banking, there's fintech, there's healthcare, there's consumer companies, consumer businesses, and so everyone has their own knowledge base or domain knowledge rather, right? How do you take that and build still a highly accurate model, and apply it to their domain and generate insights? So it is a pretty interesting problem. We built everything from research and training, and experimentation framework, to all the way up to deploying models in production. Yeah, we had a separate set of infrastructure where our data scientists could go and quickly train models on that data, and then had a pipeline that would promote those models gradually from all the way from development environment to staging to production. And yeah, we can talk more about that, but yeah,
Sure.
basically there were quality gates which evaluated those models, and if you pass some certain benchmarks, then you would get to production.
Sure. So Arpit, it will be good to kind of maybe throw some light on the size of the team, and what uh, part was kind of dedicated towards the research side, and then how many people
Yeah.
were, just to kind of set the context there, and also a little bit maybe talking about the marketing cloud and the other vertical of Salesforce as to what it used to do for its customers, so that people have that context, and then we can dive into the individual parts of the ML infrastructure there.
Yeah, sure. So there was a research team. I don't remember the exact numbers now, but there were hundreds of
Yeah.
researchers. There was an applied scientist or applied science team, and then there was the engineering team. And the research team, as the name goes, they were focusing on novel research problems, so publishing research papers, which is very different from applied science team. They were focused on pure product data science use cases. Um, and then the engineering team was basically that ML platform team, which I was part of. And we were responsible for building all that platform and infrastructure, which could support the research scientists and the data scientists. Yeah, that was the separation.
Okay. And
Yeah.
these products, like the marketing cloud and the cloud of Salesforce, like,
Right.
what was the major
Yeah.
uh, distinction there?
Um, So on the marketing cloud side, as you can imagine, right, customers of Salesforce, they would have marketing campaigns and social media campaigns where they would publish, images or text, or links, to their websites and all of that. And so we used to basically, gather all that data and train a model on top of it. And then eventually, when they publish the campaign or publish the images on social media or other marketing or ads, websites, um, the models used to then classify or detect objects in the images, and that's how they understood how the product is being used. Oh, actually, sorry, they used to run marketing campaigns, but then they used to also analyze images on social media, actually, to understand where they took a picture of the product, right? So if you're, let's say, drinking, I don't know, an energy drink on a beach, then that's how the business would understand. Okay, this is the bottle of the energy drink on a beach setting, and so now that people are drinking this beverage on the beach, and so probably you could focus the campaign there or understand better your customer personas. It's probably a poor example, but something like that. And then on the service cloud side, we had chatbots where the intention was that to avoid transferring the case over to a human agent, right,
Okay.
and automate the answers for the customers, to obviously optimize the cost. So someone like Adidas or Nike, if you go to their website, you'll see a chat agent, and you can just directly interact with the agent, and the agent will answer the questions instead of a human agent. So that pipeline was backed by our platform, where all the real-time requests were sent to our service that used to then understand the utterances in the chat and then respond with you know the answers to those questions.
Got it. Understood.
Yeah,
Cool. Awesome. Uh, let's now dive Arpit a little bit into the actual infrastructure. Maybe if you can give like a quick overview of the high level infrastructure, and then we can dive into individual parts as well. Like
yeah.
how what was the tech stack on top of which the overall platform was built, and why the choice of the tech stack, and so on. To start with, yeah.
Got it. Yeah, so we were running on AWS, and all of the compute was um, managed by Kubernetes. We had a mix of GPU clusters, depending on the use case. We used to allocate capacity differently per cluster, and also there was obviously separation of clusters between the research team and the applied science team and the engineering team. Um, yeah, and then because we ran Kubernetes, we could easily deploy any type of machine learning framework, whether TensorFlow or PyTorch. And yeah, there was on the training side, we had basically, and that's where the platform begins, right? But really, the infrastructure was really simple. There was a structured database, like a SQL database, and there was unstructured, file store or a flat file store rather, like S3. And yeah, we used to manage data uh, between the two. And then the platform was a mix of an orchestrator for training, a real-time prediction service, batch uh, uh, prediction service, and then obviously front-end API to manage all your typical user operations,
Got it.
authentication, authorization, stuff like that.
So Arpit, you mentioned that the clusters on top of which the researchers versus the applied scientists plus the final like the engineers, the ML engineers worked on was completely different. What is the reason for the
Yeah.
separation of these clusters? And using Kubernetes, like how did this part become easy for you? Yeah.
Yeah, purely because of the use cases between the difference in the use cases between the teams, right? So on the research side, um, they their intention was to publish, to do novel research and publish a paper, and so they almost had nothing to do with the customer data there, right? They were mostly building in the public domain, and the difference on the other side with the data science was very much the intention of improving the customer workflows and generating insights, and so they obviously had to work with customer data, and so that infrastructure looks very different. There's more security, there's more gates in terms of acquiring the data, being able to train on that data, and in a lot of cases even anonymizing the data and stuff like that. So that was the primary differentiation. And then just purely on the compute side of things, the the scale of the experiments that the research team ran was very different than the data science team
Okay.
that they used to run. And so yeah, there were those were the two driving factors for the building that infrastructure slightly differently.
Got it. Got it. Understood. And so, for the models that ultimately were going into production, like what was the prototyping framework? Like what was the interface for prototyping? Did people use hosted notebooks slash VS Code? And how did you kind of have that setup? Like what powered that setup?
Yeah, yeah, it is actually, now that I think about it, it was pretty simple. First phase was launching a Jupyter notebook, because at the very beginning, a data scientist or research scientist wouldn't know um, what model is the best suited to solve a particular problem, and so the intention there is sort of in real time run more short short-term experiments or experiments that don't run for a very long time or a very large data set. And so the intention was to get that confidence in that neural network or that architecture. And so it was based on Jupyter notebooks, right? So you could very interactively in real time quickly author an experiment, run that experiment, and see get a hypothesis, right, basically. And then you could easily transition from the Jupyter notebook to a long running job on a large scale cluster, um, so that the job could run on a very large data set for a longer time, while producing obviously all the metrics in real time as you go from one epoch to the other. And then eventually you could promote that model into the staging and eventually production environment where you followed the same orchestration pattern as the one after the Jupyter notebook. So we built what we called as a training and experimentation SDK,
Okay.
which allowed the researchers and data scientists to quickly pull the data and to quickly launch an experiment on the infrastructure. And so there was basically all the boilerplate code that we took care of in terms of pulling the data, pushing the metrics, uh, allowing the data scientists to plug in their training code,
Okay.
and not having to worry about all the system dependencies and all the compute side of things. Yeah.
Got it. And like this hosted Jupyter notebooks, like we've heard about a number of companies trying to host their notebooks, and issues around
Yeah.
user authentication and others. Would love to understand, like, what were some of the major challenges you saw when you had to kind of host notebooks that people were using at such a large scale and with so much data.
Yeah.
In sense, yeah.
Yeah, that was certainly interesting. So it was mostly, I wouldn't say complex, but mostly sort of more involved on the production side of things or the consumer data side of things, because all the data was sensitive, so we had to have a level of approvals, and so that part was more sensitive. And so we had, on the authentication side, a number of approval workflows is what we used to call it. And basically you had to get approval from a certain person in the team, most likely your manager or whoever is the leader in that org. And after that you would get access to that data, and you could then uh, run your experiment
Uh,
through that hosted Jupyter notebook in a contained environment. So the data is still protected, and then once you run the experiment, uh, the the environment or the notebook would be destroyed. So there were basically a ephemeral notion to that. But then obviously all the artifacts that are generated, like model and the metrics and the logs, all of that would be persisted. Um, so yeah, that was all internal. I But you can assume there was a notion of authentication where it is all internal API driven, and the notebook was basically integrated with the internal systems, which allowed those approval workflows and authentication through that. Yeah.
Got it. Understood. And given like a lot of the work was like for the chatbots and all in terms of using large models, which probably will be using a lot of GPUs and a lot of long running jobs.
Yeah.
So, what did you do, Arpit, around managing the cost infrastructure on this prototyping phase before models were going to production? Like, was that a concern? And if so,
Yeah.
like, what was there versus if you had to kind of do that today, how would you do it?
Yeah. I mean, GPUs are obviously, as you know, like it's very are pretty expensive, and there's not a lot that you can do in terms of saving costs there. There probably just really two things, right? One is if you're on a public cloud, you can get a reserved capacity for yourself, if you know what you're doing, right? So you can allocate that capacity and get a discount on that pricing. And then beyond that, if you still need any more capacity on demand, then you can use auto scaling, right? So you cut down on the unused capacity whenever you are not running an experiment. So those are the really two things, that you could do the most in my experience, at least. um, because everything else then requires one a lot of engineering effort, right? If you are going
Mhm.
to have an architecture like spot instances, one, I doubt how well supported that would be in AWS, given lack of availability of GPUs in some regions in AWS. But even if they were, then the engineering effort involved there is pretty high, and also because of the notion of training jobs running for a longer time, you can't really leverage that architecture. But that's where you could probably save the most. So yeah, really, then just two options, which is reserving capacity and getting a discount, and then two, in case you have some surge on the on-demand side because you're running fairly large experiment, then making sure you auto scale. So that's exactly what we did for the most part, to save on cost. Yeah, and that's pretty much, I think, in public cloud at least. Um, I would say that those are the strategies that would apply still date. Yeah.
Got it. And this entire framework, the interface for prototyping for the developers. Did you have any additional
Yeah.
internal things to make it easy, like like say the operator-based framework at Facebook, or say the workbench-based framework like at Uber, or was it
Yeah.
completely at the hands of the developers as to how they wanted to use it? So, love to kind of hear a little bit.
Yeah. So it was um, a mix of both, but it was also at the same time very opinionated, right? Because we provided, like I said, the training and experimentation SDK, we
Hmm.
abstracted a lot of the complexity that the data scientists didn't have to worry about with respect to scheduling their jobs, um, pulling and pushing the data and all of that. They just had to call literally a Python API or a function, and then that took care of it. Um, and then there was still a workbench type solution for the interactive experiment. And then if and for the experiments that were launched in the background using the SDK, um, you could still track, the experiment progress, the metrics, the logs, all of that in the workbench dashboard. So it is a mix of both, I would say. So it is really the choice of the data scientist how to use the platform, but it was still very much opinionated. You couldn't do a really free form style
Interesting.
experiment. Yeah, yeah, yeah,
Okay, interesting. And from this prototyping to kind of moving models to a test environment, and then from there for promotion. You mentioned there was like an automated flow which used to move models as well. So what did that
yeah.
automated flow rely on, and how did you kind of build that automation around the movement from one environment to another?
Yeah. So we kept the notion of golden data sets, right?
Okay.
For every domain. And so our data scientists could then launch a test experiment in each of the environment and see how the benchmarks look like for those golden data sets. And eventually there was also some randomized sort of data sets that they ran experiments on. And so using those two benchmarks, they could decide whether to promote a model into the higher environments or not. And it was again through the workbench. You could simply literally click on the promotion button or promote button, and that used to then move that model um, into production. And this was actually the interesting part, right? Because Salesforce is a multi-tenant system, uh,
Correct.
we didn't really have the model artifact really moving from you know a lower environment to a higher environment. It was actually the model code, the neural network, the architecture that you used, because every customer had a different data set, and so we had to produce a model per data set, per customer, per data set, right? And they could have, so one customer can have hundreds of thousands of data sets, right?
Right.
And so we basically built hundreds of thousands of models. And so that was the challenging part. Like, how do you go about, you know, one, building a model that works on all these sort of domain agnostic data sets? And that's why the notion of golden data sets to some degree helped, and then sort of randomizing, training on different types of data sets. So there was a lot of automation built around that. But the promotion process was kept intentionally slightly manual because you wanted to make sure
Okay.
that your model performs, beyond a certain threshold on, n plus one types of data sets. Yeah, that was the whole process. Yeah,
Yeah. So basically, understood about the promotion flow. So, Arpit, let's go into the serving layer, right? Like you mentioned about uh, uh, tens of thousands of data sets, and then imagining Salesforce has
yeah,
100,000 customers. That's like millions and millions of models.
yeah,
Like, uh,
yeah, yeah.
how did you kind of build the serving layer that powered this model? So, would be great to learn. What were the key considerations first of building this, and then
Yeah.
how did you kind of choose one versus the other architecture?
Yeah, we had actually several iterations of that, and that was the team that I was leading to build basically a multi-tenant real-time prediction service. And as you mentioned, right, the challenge was exactly that, which is you have now, thousands of tenants, and they have hundreds of thousands of data sets, and so that's why they have at least hundreds of thousands of models, if not millions. And so, how do you, not only train them, but also serve in real time, right? And the training part was actually easy, relatively easy, in the sense that training inherently just, it takes it's a slower operation, or rather an async operation, right? And so it's just going to take some time.
Yeah.
But real-time serving, as the name goes, supposed to be, like a request response type of workflow. And so we had the challenge of serving these models with an SLA ranging from 100 milliseconds to all the way up to, 300, 400 milliseconds. And we had a variety of, models. So we had some models who were actually as small as 50 megabytes, and some models were
Hmm.
as big as, over a gigabyte, slightly over a gigabyte. Um, and so, yeah, we had several evolutions. The very first one was obviously, like, the simplest one. Uh, Once you train a model, the metadata was available in the, structured database, like a SQL database, and then you would have the model artifact on a file store. So you get a request, you look up whether, after obviously authentication, authorization, you look up whether this model ID is present, and then you pull up the metadata. Using that, you will figure out the location, you get the model artifact, and then, you untar it, unzip it, whatever, decompress basically, and then load it on the GPU, run an inference. So it worked when the model sizes were really, really small, like, 40, 50 megabytes, because over the wire, it's not a big deal to download something like that. Again, if you've architected your infra right, in a way where you have regional buckets, and, the network architecture supports, lower latencies and all of that. So that worked well for a while. But then, as the complexities in the model grew in terms of the model architecture, and so the size
Yeah.
of the model, this was not scalable. And so then we eventually started sharding, our clusters, because there were two reasons. One was, like I said, the complexity of the model, which also was driving the need for different type of compute, right? The smaller
Hmm.
models ran just easily on a CPU,
Yeah.
but the larger models needed, GPUs. And then in that, you could sometimes use a cheaper GPU, or, um, and then in on the other extreme, we had to use the latest and the greatest, which are the more sort of expensive GPUs. So we had basically clusters per almost per type of model. Like, we basically have an umbrella, right, which is um, NLP models, and then you have
Hmm.
something like a really simple LSTM model, and then you have something like a transformer model, right? And same on the vision side, you have a simple CNN based image classification model, and then you have all the way up to something like an object detection model, or rather an OCR model, which does sort of both images and text. And so, depending on the type of use case, we had different types of compute. Um, and so, we wrote this layer which could orchestrate basically deploying the services on this different types of uh, clusters, node groups,
Right.
right? And then they pulled still the model from the file store, but then there was a layer of caching built into it, where we could use the metadata around who's a what tier of pricing does a customer have, and
Got
based
it.
on that we used to dedicate certain resources for that. And just in general, there was a notion of LRU caching, right?
Sure.
And so based on that, we could make sure that the most requested models always had higher or rather lower latencies. Um, and then eventually, if you retrain a model, if you just added a new type of model, right? The first request obviously used to suffer latencies, but then subsequent ones used to cover,
Sure.
and so they used to be under the SLA. So we became creative that way. And then eventually, again, the third iteration was, um, and this is probably one of the hard learnings that we had, which is we allowed our data scientists and research scientists to use the framework of their choice, right? So someone is using TensorFlow, someone is using PyTorch, someone is using MXNet or whatever, something else. And
Yeah.
so when you do that, it is very hard to make sure that you can uniformly serve those models, right? Because the frameworks dictate a lot, and especially the latencies, right? And as engineers, we don't control, or we can't control the code of the model, especially if you have so many different types of frameworks. So eventually, we narrowed it down to just one or two frameworks, and then spent the time to optimize the models. And so that worked for a while. And then eventually, the fourth iteration was actually model conversion. So we actually compiled the model into a uniform format. So regardless of whether you train in TensorFlow or PyTorch, we used to basically serve the model in the same format, and that's how we could then make sure that we tighten the serving code and optimize it heavily for that type of format. And so that eventually gave us the most uh, boost in performance and serving the models at a large scale, but at very, very low latencies. Yeah.
Interesting. And two questions here. First one is how did you kind of ensure that the models that were written in different formats served in the same format, and what was the
Yeah.
structure that uh,
Yeah.
powered this behind the
Yeah.
hood?
Yeah, that's the secret sauce, right? But I can try to answer that. One was obviously heavily benchmark, right? And then two is try to be within the bounds of most widely supported operators, right? Or other operations, right? Within a framework, if you used what was most commonly used and had support for, then you could easily convert the model. But if you implemented a custom operator, then that obviously was a high friction conversion. So yeah, we and it was pretty high touch at that point. If something really needed a very creative way of training a model, then we just sat down with the research scientists and then figured out a way to optimize it.
Got it.
But that's the thing, right? With enterprise AI, so many use cases don't need you to like innovate in a way which
Right.
is very novel. 95 percentage of the percent of the use cases are just easily solved by off the shelf models, and doesn't really need like I said, a novel technique. So that came in handy, and so we could optimize for that 95%, and the remaining 5%, even if it was slightly slower, they were also not the most used models, so it just worked out that way. Yeah.
Okay. And with just a follow up question here, like with frameworks like Onex that kind of kind of try to do this where you can
Yeah.
uh, standardize the
Yeah.
formats. Like, with Onyx coming in, I believe like when you all built it at that time, it was not there or was not stable. So does that kind of solve some of the problem, uh, like uh,
Yeah,
in terms of having the common formats?
yeah, it does. And so Onyx is one of them, but I would vouch for Triton and TensorRT,
Yeah.
NVIDIA's inference server. I think those guys have really done a great job. And while during my last year at Salesforce, I closely partnered with that team, and we built a lot of really cool features in there for model benchmarking, model conversion, um, even on the side of dynamic batching and multi GPU sort of replicated model inference and stuff like that. So yeah, I think that should solve for a large set of real time inference use cases. Unless you're doing something really really complex and really novel, I don't think, especially in production again, right? So that yeah.
And then the other question is around the multi-model serving part, right? Like uh, you all had huge varieties of models, so you were in some way doing the multi-model serving, but at that time probably Triton and SageMaker kind of frameworks were not there. So how did you implement the multi-model serving and the hot reload kind of a system internally?
Yeah, I mean it was like I said, right? It just using high memory instances and store, as many models or hold as many models as you could on the GPU. There was obviously swapping, and that was the cost that we had to pay. So we minimized that cost using some sort of a variation of LRU technique, and then sharding sort of customers on different clusters. Um, and I think it worked pretty well for a long time. I don't know if that has changed now since I left, but that I think plus the optimization on the latency side, serving side, I think that scaled pretty well. Yeah,
Got it. So Arpit, like it would be great to hear a little bit of some of your favorite innovations that you and your team worked on at Salesforce. Salesforce, like uh, of all the things, like what was something that you really enjoyed as a challenge building, and maybe
yeah,
describe the problem statement there and diving a little bit more.
yeah. Yeah, the real time inference really, right? Like I mean that was my favorite things to work on, and I think by the end of it we also were able to file a patent on it. So it was a great engineering um, feature that we added to the platform. It was the most widely used, the most used feature actually. We were doing double digit millions of predictions per day, and so yeah, it was very satisfying to see that getting used by so many customers. Yeah,
Interesting. And Arpit, so thanks a lot for sharing the details on the Salesforce ML platform. Curious, like as you advise other
yeah,
startups on building their ML infra today, like what has changed
yeah,
from the way you build it at Salesforce versus building it for a mid-sized company that probably does not have as huge the data sets and the number of models that
yeah,
Salesforce has, but how would you think of building an infrastructure around that? uh,
yeah. I mean, now there are so many alternatives available that give you a lot of these things out of the box. You don't really have to build much, honestly. If you just really have to integrate into your data stores pretty much. But yeah, I mean, I could probably take True Foundry here. So if I obviously recommend True Foundry, being an investor in True Foundry. But uh, you know, for whatever reason, if someone at a really early stage, at a startup is trying to build something around ML or within in that space and needs to train, I always err on the side of simplicity, and so don't build an orchestrator, don't even think about all those things. Literally, just write simple Python, scripts to just pull the data, train on one single machine with multiple GPUs if you need to, and just implement some sort of orchestration around, not really orchestration, probably the wrong word to use, but um, be aware of sort of just the ephemeral side of things, which is like you should be able to train and then get rid of the instance so you can save the cost. But yeah, I typically just like suggest to keep it really really simple. If you just want to train one or just a few models, right? No need to really like go all out and try to build something from scratch or even like run anything open source. But beyond that, to your point, right? If it's a small to mid-size company with fairly established ML workflow, then yeah, I mean, there are some open source tools that you can directly use. But something like True Foundry is obviously out of the box, and so I more often than not just recommend that. Yeah.
Got it. And one other question that comes in mind is, what were some of the, or any one design decision or a decision that you took at Salesforce that looked great at that time, but now if you had to go back, you'll probably change it given the lot of evolving nature of the space.
Yeah, I wish we built the training and SDK slightly sooner, and the same sort of concept on the inference side of things, where a data scientist used to ship a container really, and we deployed the container. Eventually, we came up with a common interface using protobufs
Okay,
to have a uniform contract. But in the beginning, as because we were also basically building as we were growing and scaling, and so there was always this tech debt. But yeah, I wish we took that decision slightly sooner to build the training SDK and the inference sort of protobuf layer. That way we could remove so much organizational friction that we had between the teams,
got it.
and just probably would have accelerated some of that growth. Yeah.
Interesting. One more question is around the things that came into the system from a reliability and security standpoint, like given the the
Yeah.
importance of data privacy and all. Like, what were some of the things in the system from a security standpoint or
Hmm.
from a reliability standpoint? Like, um,
Yeah. Um, Obviously, a lot of approval workflows around the data set um, prior to deploying the model in production for all the customers. So that I already touched on. But really, from security standpoint, um, there was a complete isolation of the production environment as you typically would have. We had HIPAA compliance, we had ISO compliance, all of those security standards and certifications. Um, but purely from um, training and inference side of things, we were a multi-tenant system, so naturally all of the auth covered all of that. So only one particular customer could access their own data, and the boundaries were kept, very uh, um, sort of obvious using that. But beyond that, yeah, I don't think there was anything special about it. Yeah, but the reliability
got it.
side of things was, yeah, like
Arpit,
just a lot of, yeah, I think, yeah, the reliability side of things was basically like just enough redundancy, high availability that you would typically um, you know build into a platform.
got it. Arpit, this question comes up quite a bit when we have discussions with other folks in the industry. So, want to understand your view. Like, how do you kind of think of the machine learning infrastructure platform
Mm.
versus, say, a software uh, deployment platform? What are the commonalities? What are the differences? What is your view on that?
Yeah, like, do you mean like typical infrastructure versus ML infrastructure, right?
Yeah, yeah,
Yeah, yeah. Actually, it's not very different, right? If you think about it, you need so several layers, right? So there's a data layer, there's the compute layer, there's still an orchestration or a async layer, async job layer, and then there is something like an auth service, an API gateway, right? Um, and obviously the backend service side of things. What changes is really the compute and the nature of the jobs. So even if you're not running an ML workload, you would still run probably some sort of analytics workload, some sort of data engineering workload, right? And that still has that async notion, the orchestration notion. So it's still there. Like an inference service, you would run still a backend service. Obviously, it wouldn't use GPUs. Um, Instead, it would just rely on typical standard CPUs, and so. But it's still at the end of the day a long running process, similar to a real time prediction service. Um, the data side of things is probably different, where you may have a notion of data lake or an ML lake for a ML shop, which you may not have for a typical standard infrastructure. But other than that, I think the stack looks pretty much the same, right? The tooling really changes, but like you may just get away with a simple airflow type of orchestration system, but for an ML workflow, you may need something more specialized, and so I think they look pretty much the same to a certain degree. It's really the tooling and the platform that changes. Infrastructure, I think, is yeah, you could reuse a lot of. In fact, we did that, right? We had a lot of typical backend services, and so we actually ran them on the same sort of infrastructure. Yeah,
Interesting. And that's great to know, because when we talk to a lot of companies, they think that the ML ops pipeline is going to be completely different, and they need a completely different set of skill sets.
no,
Uh, so,
yeah,
so
yeah. So actually, I could take this back to your question. Which is at Skiff, we don't run any machine learning workloads yet, at least. But there's one tool that's common that I had to build at Salesforce and that I built again at Skiff, which is, and this is probably slightly nuanced, which is if you are running a Kubernetes cluster, you still need something to deploy to that Kubernetes cluster, right? Now, you may
right,
build an ML platform on top of Kubernetes cluster, and it also has a notion of deploying a model, deploying a training job. So that tool actually, now that I think of it, is exactly the same. It did pretty much the same thing, right? So I built this tool at Skiff, which takes a DSL where you can mention, this is my container, this is these are my resources for this service, like, so whatever CPU and memory, and whether it's a stateful service or whether it's a stateless service, and what type of ports you need to expose, right? So that's the DSL I take, and then I deploy basically that service on the Kubernetes cluster. And we basically did the same. The nature of that deployment was slightly different, where it was either a training job or a inference service. So if you think about it, in the Kubernetes world, it's actually the same. There's no difference. Yeah.
very interesting. Very interesting. Arpit, now turning hats to the investor side, like as an investor, like while you are
Yeah.
still leading the infrastructure, what are the things you are keeping your
Yeah.
eyes open to for investment into the MLAI space, and maybe a little bit if you can touch on how you see the generative AI space evolving, and what are your views there as well? That will be great to hear.
Yeah. So yeah, at Builders Fund, we invest in AI infrastructure, cloud infrastructure, privacy and security space, and specifically on the AI side, I mean, there's just so much opportunity right now. So we are always, obviously, the core thesis for us is it has to be a SaaS product, and it can, it doesn't matter if it's a B2C or a B2B product, but it has to be a SaaS product with a very clear, problem statement, and a very well defined, value generation. But specifically for me, I always like, in that developer productivity and platform plays, and that's how True Foundry happened, and so we really like what you guys are doing. So that is sort of my sort of I want to say sweet spot in terms of investments. But yeah, definitely anything from B2C to B2B in the AI space. um But yeah, going to the generative AI, I think, I mean, this week was probably the most eventful in the AI domain, right? There were so many releases in terms of models and then frameworks. PyTorch 2.0 released, um, GPT released a new version. So there's just like so many new things coming up. I think that it's too early still. There are two sides of it. One is the application side of it, and then one is the technology or the platform side of it. And so, really, on the platform side, there's I think there's only OpenAI that's building new technology and new platform um, at a very rapid pace. There are other startups who are sort of following suit, but I think they are probably the leaders, right, and have the most leverage on the market right now. On the application side, I think there's just ton of opportunity. There's so many verticals that you could use now. Something like a large language model. I think it's just going to be very exciting. So definitely a lot of opportunity for even small players on the application side. Um, Personally, what I am interested in is anything that can um, vertically integrate into a business, right? Which is just the LLM as it is obviously a very um, strong technology, but being able to have that access to that private data, right, in the private sector, whether it's healthcare, fintech, CRM, even something like Salesforce, and then being able to apply a large language model on that data is, I think, going to be the next sort of big opportunity. Anything in the public domain obviously is helpful, and it's um, like a accessory to your day-to-day workflows. But I think the true business value or true value generation is, I think, that vertically integrated sort of businesses. Yeah, but again, too early. We'll see. We'll see
Got
how
it.
it goes. Yeah.
Arpit, thanks so much. One final question before we end this is any advice you have
Yeah.
for the ML engineers or the ML infra folks that are building out infrastructure for ML operations in their companies? Or what should they be prepared for, and any advice for them? Yeah.
Wow, that's a very difficult question. But what should they be prepared for, or what they should be doing? Honestly, I think I would say that focusing on a niche at this point, in terms of either a very large scale operationalizing a large scale AI workflow is probably going to be the next set of difficult one of the difficult challenges. Like you could, if you were something like Salesforce, if you were something similar to Salesforce or in healthcare or fintech, and you had to deploy something like LLM at scale, I think that is probably the next sort of most challenging problems to solve. And then yeah, focusing on that would be very useful. Yeah.
Cool, awesome. Thanks, Arpit, for taking time for this call with us. It was really exciting talking about your journey as well as the details of the internal platform at Salesforce. It's a pleasure to have you.
Yeah, thanks